Sai Ram to all. Previous class we have studied about speed and velocity. What is the difference between speed and velocity? Let's we solve some problem related to speed. The first example is the odometer of a car reads 2000 km at the start of a trip and 2400 km at the end of trip, and if the trip took 8 hours, calculate the average speed of the car in kilometer per hour and meter per second. First of all, what do you mean by odometer? Odometer means which reads the distance traveled by the vehicle, vehicle. What is distance traveled by the object? How many kilometer that vehicle is traveled? How many kilometer it is traveled? It is read by odometer. So every vehicle which contains odometer. Now look at the question. The odometer of a car reads 2000 km. What do you mean by 2000 km? At the start of trip, when it starts the journey, what is the reading of that odometer? It is 2000 km. When it starts journey or start of a trip and 2400 km at the end of a trip, at the starting it is 2000 km. Then end of the trip, what is the reading? 2400 km. Now what is the total distance covered by that car? At the start it is 2000, then end of the trip it is 2400. At the start it is 2000, at the end of the trip it is 2400. So 400 km. What is the distance traveled by the car? It is 400. Why it is 400? 2400 by 2000. 2400 minus 2000 equal to 400 km. Now write the datas. What are the datas are given? First is find the distance traveled by the object. Distance traveled. Distance traveled equal to 2400 minus 2400 minus 2000. What do we get? It is 400 km. This is distance traveled. Now, if the trip took 8 hours, so what is the time taken T? It is 8 hours. It is given in hour. Now calculate the average speed. Speed equal to, what is speed? Speed equal to distance traveled or average speed. Now it is average speed, total distance traveled by total time. What is average speed? Average speed equal to total distance traveled by total time. What is the total distance traveled by this object? It is 400 km. It is 400 km divided by, what is the total time? 8. Now 8 ones are 8, 5s are 40, then 0. So 50. 50, what is the average speed? What is the SI unit of average speed? The SI unit of speed is meter per second, but it is given that kilometer and hour. So 50 kilometer per hour. Now car travels with the speed of 50 km per hour. Now average speed of the car in kilometer per hour and also find average speed of the car in meter per second. So convert this into meter per second. How to convert this meter per second? It is very simple. 50 kilometer per hour. What is the meaning? 50 kilometer per hour means here 50 into, this is kilometer per hour. Now kilometer, convert the kilometer into meter. So 1 kilometer means 1000 meters. So into 1000. Kilometer is converted into meter. 1 kilometer means 1000 meters. So 1000 meters divided by 1 hour means 3600 seconds. Why? 1 hour means 60 minutes. In 1 minute 60 seconds. So 60 into 60, 3600. So 1 hour means 3600 seconds. It's a very simple method. How to convert kilometer per hour into meter and second, kilometer to meter, hour to second. The easy method is 1 kilometer means 1000 meter. 1 hour means 3600 seconds. Now, two zeros cancel. After that, 50 into 10, 5. After that, 2 zeros, that is 500 divided by, here it is 36. So, write 36. 2 ones are 2, then 2 eights are 16. Here, 2 twos are 4, 10, 2 fives are then 0. 2 nines are 2 125s are. Now, 9 ones are 9, 3 is left, 35. 35 means 9 threes are 27, 8 is left. So, put a point, because 8 does not divided by 9, it becomes 80. 9 eights are 72, 8 is left, once again it is 8 and it continues 13.8888. So, we can write it as 13 point, round of the value we get 13.9. It is not kilometer per hour, now it is converted into meter per second. So, the answer is 13.9 meter per second. So, average speed of the car in kilometer per hour is 50 kilometer per hour and mean meter per second is 13.9 meter per second. It's one of the simplest form problem. This is the method of solving. Now, second example. Usha swims in a 90-meter long pool. Long pool means swimming pool. She covers 180 meter in 1 minute. Look at the question. Usha swims in a 90-meter long pool. Now, this is a pool, swimming pool. What is the total length of this pool is? This is A, this is B. What is the total length? It is 90 meter. So, this is the total length of the pool. So, Usha swims in a 90 meter long pool. She covers 180 meter in 1 minute. 180 meters. So, he starts the swimming from A, point A, then start and moves to B, then come back in the same path to reach A. Why? Because she covers 180 meter. 180 meter. If she travels, she moves, she swims, A to B means 90. Then B to A means plus 90. So, it is totally 180 meter. It is also given in the question. Usha swims in a 90 meter long pool. She covers 180 meter in 1 minute. In 1 minute. Time taken is 1 minute by swimming from one end to another end to the other and back along the same straight path. So, how she swims? A to B, then B to A, and totally she covers a distance 180 meter. Straight path. Find the average speed and average velocity of Usha. Why it is now velocity? Because she moves in a straight line. She swims in a straight line. So, it is velocity. Now, velocity, find the average velocity as well as average speed. First, find the distance travelled by Usha. What is the distance travelled by Usha? Tell me. Distance travelled equal to. What is the total distance travelled by Usha? Usha swims in a 90 meter long pool. She covers 180 meter. She covers. The total distance covered is 180 meter. So, distance travelled is 180 meter. Because she starts the swim from A, then B, come back in the same path and reaches to A. So, 90 plus 90, totally distance travelled or distance covered is 180 meter. Now, distance travelled is 180 meter. Now, tell me, what is the displacement? Why displacement is required? To find the velocity. Now, we have to find the average speed and average velocity. So, tell me, what is the displacement? Can I write 180 meter? Is the displacement? What is the displacement? What do you mean by displacement? The shortest distance between initial position to final position of the object. That is displacement. Any idea about displacement? Can I write 180 meter? No, because she starts the swimming from A, then reaches to B, come back in the same path and reaches to A. Now she starts the swimming from A, ends the swimming in A. Now she is in A. Start the swimming from A. What is the shortest distance? That is 0. So displacement is 0 meter. What is the displacement? 0 meter. Now find the average speed. So average speed equal to, what is the formula? Total distance traveled by total time. Now total distance traveled is, what is the total distance traveled? 180. What is the total time? Total time is, write the timing. What is the T in? Time equal to 1 minute. 1 minute means 1 minute, or it is 60 seconds. 60 seconds. Why convert to 60 seconds? Because SI unit is meter per second. Here it is given in meter. Now it is in minute. To convert minute into second. Total time is 1 minute. Now I am writing 1 minute, or into, just look at this, 180 is in meter. So there is no need of conversion. So write into 1. 1 minute, it is 1 minute now. 1 minute means how many seconds? 60 seconds. So divide by 60. 0, 0 is cancelled. 6 ones are 6 3s are. So 3 into 1 is 3 by 1, or it is, we simply write it as 3 meter per second. What is the total, what is the average speed of the swimming? That is 3 meter per second. So average speed of velocity of Usha is, average speed of Usha is 3 meter per second. Now this is average speed. Now find the average velocity. What is average velocity? Total displacement by time. What is total displacement? Total displacement is 0. So 0 by, what is the time? Time is 1 minute or 60 seconds. Or it is 0 by 60. What is 0 by 60? 0 by 60 is 0. So this is average velocity. So average velocity is 0. What is the average speed? That is 3 meter per second. Next concept is rate of change of velocity. Here is one example. When an object move along a straight line, with uniform motion. What is uniform motion? It covers equal distance in equal intervals of time. So object or any body or any vehicle which moves along a straight line with uniform motion. Now tell me, in this case the velocity is constant or is changing with the time? Is it constant? No. Yes, it is always constant. Why it is always constant? Look at the example. A car moves A to G. This is a straight line. So car moves along a straight line with uniform motion. What do you mean by uniform motion? It covers equal distance in equal intervals of time. In 1 second it covers 1 meter. Next 1 second it covers 1 meter. In next 1 second it covers 1 meter. In the next 1 second it also covers 1 meter. So what is the velocity? What is velocity? Velocity means displacement by time. That is 1 meter is the displacement. Time is 1 second. So here is our velocity is 1 meter per second. In this case B to C, it is also 1 meter per second. In C to D, what is the velocity? It is also 1 meter per second. D to E, it is also 1 meter per second. Why? Because it covers equal distance in equal intervals of time. So velocity is constant. Very important. When velocity is constant? If an object moves along a straight line with uniform motion. Now velocity is constant. If object move along a straight line with non-uniform motion, now velocity is same, velocity is constant. Can you check? In 1 second it covers 1 meter. In 1 second the displacement is 2 meter. Next 1 second the displacement is 3 meter. Next 1 second the displacement is 5 meter. Next 1 second the displacement is 6 meter. Now tell me, the velocity is constant? Now body or a object move along a straight line with non-uniform motion. The motion is non-uniform. It covers unequal distance in equal intervals of time. In first 1 second it covers, the displacement is 1 minute. Next 1 second it covers 2 meter. The displacement is 2 meter. Next 1 second the displacement is 3 meter because it is a non-uniform motion. So what is the velocity in this? 1 meter per second. A to B, the velocity is 1 meter per second. In the next B to C it is 2 meter per second. Next it is 3 meter per second. So velocity is changing. Velocity is changing. So the velocity is changing with respect to time. So the rate of velocity changing is called acceleration. So change in the velocity of an object with respect to unit time is called acceleration. So what is acceleration? Rate of change of velocity is known as acceleration. So this motion or this velocity is called, the rate of change of velocity is called acceleration. Why it is acceleration? There is no any acceleration? No, because the velocity is constant. But in this, the rate of change of velocity, 1 meter per second, next 1 second it is 2 meter per second, this is 3 meter per second, velocity changes with respect to time. So the rate of change of velocity is called acceleration. Very important. What is acceleration? This is called acceleration. This is example for acceleration. What do you mean by acceleration? The rate of change of velocity is called acceleration. Now this is a ball. If I throw a ball towards upward, this is also example for acceleration. Just look at this. This is a ball, moves towards upward. If I throw upwards, this motion, this is also accelerated motion. Why it is accelerated motion? Now it is in rest. Now it is in rest. When I throw upwards, it moves, it means it gains the velocity. The velocity is changing. 0 meter per second, 1 meter per second, 2 meter per second, 3, then 4, 3, 2, 1, 0. At one instant it becomes 0. So 0, 1, 2, 3, 2, 1, 0. After that, once again the velocity is increasing. 1, 2, 3, and when I catch the ball, now once again its velocity becomes 0. So it is also acceleration. The rate of change of velocity, the rate of change of velocity is called acceleration. Now acceleration equal to, how to find the acceleration? Acceleration equal to, it is calculated like this: final velocity minus initial velocity. Final velocity minus initial velocity divided by time. This is acceleration. So what do you mean by acceleration? Final velocity minus initial velocity divided by time. Why? The formula for acceleration is final velocity minus initial velocity divided by time. Yes, because this is a straight line. One object which at rest. So now tell me, what is the initial velocity? Object at rest, it means, or we can write final velocity as v. It is denoted by the letter, small letter v, and initial velocity as u divided by t. Our acceleration is denoted by the letter a. So a equal to v minus u by t, all small letters. So what is a? A means acceleration. final velocity means v, initial velocity means u, then time means t. This is the formula. A equal to v minus u by t. Yes. Now, there is an example. A object starts the journey from rest. What is rest? Its velocity is 0. Now it is in rest. Now it is in rest. When moving means its velocity changes with time. So it starts the journey from rest. So u equal to 0. Afterward, it attains the velocity. It attains the velocity 4 meter per second. It attains the velocity 4 meter per second. Now tell me what is v? V equal to 4 meter per second. So final velocity is 4 meter per second and initial velocity is 0 meter per second. Acceleration equal to final velocity minus initial velocity divided by time. Now what is the SI unit of acceleration? We can directly write meter per second square. But one question arises, why it is meter per second square? Because A equal to, there is no need of writing v and u, both are velocity. So it is, we are writing v by u only. Why it is v minus u by t, not required to find the SI unit? V and u, both are velocity. So write v. Now, what is the SI unit of v, velocity? It is meter per second. Meter per second means meter divided by second. Divided by, this is A equal to v by t. V by t. Then what is the SI unit of time? It is s. Or we write s by 1. Actually it is s by 1. So 1 into m. 1 into m is m. Now like this, multiply. 1 into m divided by s into s. S into s. What do we get? Meter by second square. Meter by second square. Or it is meter per second square. It is meter per second square. Or we can write it is also ms to the power minus 2. So what is the SI unit of acceleration? It is meter per second square or meter second to the power minus 2. Very important. What is the SI unit of acceleration? SI unit of acceleration is meter per second square or ms to the power minus 2. The acceleration is taken to be positive. Sometime the acceleration is taken to be positive. What is the meaning? It is in the direction of velocity. When we taken the acceleration is positive, it means 1 meter per second square. The acceleration of the object is 1 meter per second square. What is the meaning? 1 meter per second square means the acceleration is taken in positive means the velocity is increasing. What is the meaning? Velocity is increasing. The acceleration is taken to be positive if it is in the direction of velocity. It means the velocity is increasing. The velocity is increasing like this. In first second 1 meter, second 2 meter, next second it is 4, 5, 6 and so on. So it is increasing. When the velocity is taken in minus sign, so acceleration taken in minus sign, acceleration equal to minus 1 meter per second. What is the meaning? Minus 1 meter per second square. It means the acceleration taken to be negative means if it is opposite to the direction of velocity. If it is opposite to the direction of velocity, it means the velocity is decreasing. The velocity is decreasing. This is the meaning of plus and minus. Another thing very important, if an object travels in a straight line, if an object is moving in a straight line and its velocity increases or decreases by equal amount in equal intervals of time, then acceleration of the object is said to be uniform. When we say the acceleration is uniform. Acceleration uniform means the object travels in a straight line. The condition is the object travels in a straight line. This is example. Not only a straight line, and its velocity increases or decreases by equal amounts of equal intervals of time. It means in first second it travels 1 meter. In the next 1 second it travels 2 meter. Next 1 second it moves 3 meter. Next 1 second it moves 4 meter. Next 1 second it moves 5 meter. Look at this. Now this acceleration is called uniform. Now this is uniform. Why it is uniform? In equal intervals of time, it covers equal distances. Now it is increasing. It not covers equal, but it covers equal distances. If an object travels in a straight line and its velocity increases, now velocity is increasing because first in velocity is 1 meter per second, second it is 2 meter per second, next is 3 meter per second, next it is 4 meter per second. What is the velocity? Just look at the velocity. Here it is 1 meter per second, here it is 2 meter per second, here it is 3 meter per second, here it is 4 meter per second. Now velocity is increasing. Velocity is increasing. If an object travels in a straight line and its velocity increases or decreases by equal amounts, in equal intervals of time, then the acceleration of the object is said to be uniform. Now tell me, what is the acceleration? What is acceleration? Acceleration means final velocity minus initial velocity. 2 minus 1, correct? 2 minus 1 divided by time. What is the time taken? 1. So 2 minus 1 means 1 by 1. It is 1. So 1 meter per second squared. Here, what is the acceleration? 1 meter per second. In next case, 3 and 2. 3 minus 2 divided by 1. What do you get? 1 divided by 1. What is the acceleration? 1 meter second. 1 meter per second squared. 1 meter per second squared. Just look at this. Here A to B, in 1 second it covers 1 meter. B to C, in 1 second it covers 2 meter. What is the velocity in the A to B? 1 meter per second. B to C, what is the velocity? 2 meter per second. C to D, what is the velocity? 2 meter per second. Velocity is increasing. Yes, velocity is increasing. Now find the acceleration A to B. What is the acceleration A to B? Here, or A to C? Final velocity is 2. So 2. What is the initial velocity? Is 1. So 2 minus 1 equal to 1 divided by 1 because 1 second. So 1 meter per second. Next case it is also 1 meter per second. Next also it is 1 meter per second. So this type of acceleration is called uniform. And opposite to this, the motion, an object can travel with the non-uniform acceleration if its velocity changes at a non-uniform rate. This is example for non-uniform acceleration. So there are two types of acceleration, uniform and non-uniform. Next class we will solve some problems from, related to velocity. In this class we have studied average velocity and average speed, related problems from average speed and average velocity. Then what do you mean by acceleration? What is acceleration? The rate of change of velocity is called acceleration. Sai Ram.